I am going to talk about amines. My talk will be in three parts. In the first part, we will discuss about what is an amine and how it is classified. And in the second part, we will discuss how the amines are prepared. Finally, I will go on to talk about one reaction of amine. So let's move on to the first topic, that is, what is an amine? Amine is an organic compound that all we know, and amines are the organic derivatives of ammonia. What is an ammonia? Ammonia is the nitrogen and hydrogen containing compound. Its molecular formula is NH3. Amines are the organic derivatives of ammonia. So, in, in ammonia, 1, 2, or all the three hydrogen atoms are replaced by alkyl or aryl substituents, that is known as amines. So first we are discussing the classification of amines here, that amines are classified into primary amine, secondary amine and tertiary amine. Primary amine is that here one of the hydrogen atoms in ammonia molecule are replaced by alkyl or aryl groups. So its functional group is NH2. Here you can see an example, that is alkyl group is attached to the NH2 part. So it is a primary amine, that is methylamine. You can see as an example here. Second classification is secondary amine, that is two of the hydrogen atoms are replaced from the ammonia molecule by the alkyl or aryl groups. Here you can see an example, that is dimethylamine. So secondary amine, the functional group is divalent NH. And the last classification of amine is tertiary amine. The functional group is trivalent N. Here you can see an example is trimethylamine. These are organic derivatives of ammonia, and it is classified into primary amine, secondary amine and tertiary amine. Some examples of primary amines are given here. The first example is methylamine, or its IUPAC name is methenamine. Okay, here one carbon is attached to NH2, and here two, the carbon chain attached to the NH2 part, that is two carbons. So it is ethylamine. Its IUPAC name is ethenamine. And the third one is N-propylamine. Here the 1, 2, 3. So it is 1 N-propylamine, its common name. Its IUPAC name is propan-1-amine. Okay. Here also the 3 carbon atoms and 1 carbon is attached to the NH2. 1, 2. So it is 2 propan-2-amine. Okay, here propan-1-amine, here propan-2-amine. And the next one is, you can see here 1, 2, 3. So it is 2-methyl propan-2-amine. Its common name is tertiary butylamine. Okay. And here you can see 1, 2, 3, 4. So it's a 4 carbon containing chain is attached to NH2. Here it is a double bond here. So it is but2-ene 1-amine. Okay. But2-ene 1-amine. So these are aliphatic amines. Next come to aromatic amines. So it is the benzene ring attached to the NH2 group. So it is aniline. Its common name is aniline, but it is also known as benzenamine, or IUPAC name is also known as aniline or benzenamine. Its common name is aniline. Okay. And next one is, you can see here, the first carbon atom attached to the NH2 and the second carbon atom is attached to the methyl group. So it is 2-methyl benzenamine or 2-methyl aniline, or its common name is orthotoluene. We know toluene is benzene ring attached to CH3. So it is orthotoluene. Another compound is the benzene ring attached to CH2NH2, that is benzylamine, or we can say that 1-phenyl methanamine. 1-phenyl methanamine. Methanamine is CH3NH2. Here one hydrogen is replaced by the phenyl group. So it is known as 1-phenyl methanamine. So primary amines are those amines in which one of the hydrogen atoms are replaced by the alkyl or aryl substituents from the ammonia molecule. Here we will discuss some examples of secondary amines. Its functional group is divalent NH. Here you can see an example, dimethylamine. Its IUPAC name is N-methyl-methanamine. Okay, N-methyl-methanamine. We know that the IUPAC methanamine is CH3NH2. So one of the hydrogen atom in the NH2 part replaced by methyl group, and it is known as N-methyl-methanamine. And the second example is CH3CH2NHCH3. So it is ethyl methyl amine. Its common name is ethyl methyl amine, or we can say that N-methyl ethane amine. Okay, N-methyl ethanamine. Ethanamine, we know that CH3CH2NH2. So here in NH2, one hydrogen is replaced by the methyl group. So it is known as N-methyl ethanamine. Its common name is ethyl methylamine, but its IUPAC name is N-methyl ethanamine. Next one is methyl phenylamine. Methyl phenylamine. We know benzene amine is benzene ring attached to the NH2. Here one hydrogen is replaced by the methyl group. So it is known as N-methyl aniline or N-methyl benzene amine. Some examples of tertiary amines are given here. Here you can see the functional group of tertiary amine is trivalent N. Here you can see the trivalent N, which is attached to 3 methyl groups. So it is known as trimethylamine. Its common name is trimethylamine, but its IUPAC name is NN dimethyl methanamine. We know methanamine's formula is CH3NH2. Okay. Here the two hydrogen atoms are replaced by two methyl groups. So it is known as N dimethyl methenamine. Okay. And the next one is CH3N CH3 CH2 CH3, that is N dimethyl ethanamine. Okay. N dimethyl ethanamine. We know ethanamine's formula is CH3 CH2 NH2. Here the two hydrogen atoms are replaced by two methyl groups. So it is known as NN dimethyl ethanamine. Another one is an aromatic amine. Here you can see the aniline is the parent chain, that is C6H5NH2. Here the two hydrogen atoms are replaced by two methyl groups. So it is NN dimethyl aniline or NN dimethyl benzene amine. Its common name is dimethyl phenylamine. Okay. Now let's turn to the next topic, preparation of amines. There are two methods we are going to discuss here. First one is by the reduction of nitro compounds. The reagents used for the reaction is hydrogen on palladium or hydrogen on platinum or lithium aluminum hydride or tin HCl, iron on HCl. So these are the reagents used for the reduction of nitro compounds, which is converts the nitro compounds converted into amines. Here you can see a general reaction of the reduction of nitro compounds by using one of these reagents. The nitro compounds undergo reduction to give amine. Reduction means the addition of hydrogen. So RNO2, that is a nitro compound which undergo reduction reaction. By using any one of these reagents, we will get amine, primary amine and water. And the second method for the preparation of amines is Hofmann's bromamide reaction. In this reaction, a general reaction scheme is given here, that is an amide undergo Hofmann's bromamide reaction. The amide reacts with bromine in the presence of alkali at 70 degrees Celsius. We will get primary amine and potassium bromide, potassium carbonate and water. So the CO part is removed from this and we will get the RNH2. Okay. So these are the preparation methods going to discuss here. First method for the preparation of amines is reduction of nitro compounds. Nitro compounds can be reduced by catalytic hydrogenation to the corresponding primary amines. The reagents used for the reduction reaction is hydrogen on palladium, hydrogen on platinum, lithium aluminum hydride, tin in HCl or iron in HCl. So any one of these reducing agent can be used for the reduction reaction. Here you can see an example for the preparation of methylamine. That is, for the preparation of methanamine, we can use its nitro compounds, that is nitromethane, which undergo reduction reaction by using any one of these reagents. We will get methanamine and water. Okay. And the second reaction is nitrobenzene undergo reduction in tin HCl or iron HCl or lithium aluminum hydride. We will get the corresponding amine. that is aniline and water. So any compound, any nitro compound undergo reduction reaction using these reducing agents, any one of these reducing agents, we will get the corresponding amines. Next method for the preparation of amines is Hofmann's bromamide reaction or Hofmann's hypobromite reaction. Here, the primary amide zone reaction with bromine and alkali at about 70 degrees Celsius to yield the primary amines having one carbon atom less than the parent carbon or parent amides. This reaction is known as Hofmann's bromamide reaction or Hofmann's hypobromite reaction. That is, here you can see an acetamide. Acetamide contains one CO group and second 2 methyl. So here 2 carbon containing amines which reacts with bromine in alkali. We can use either potassium hydroxide or sodium hydroxide. At 70 degrees Celsius, we will get CH3NH2 methanamine from acetamide. Here the CO group is removed. So the product of this reaction is that the primary amines having one carbon atom less than the parent amides. Okay. In this parent amide, 2 carbon atoms. Here the product only 1 carbon atom. So this reaction is known as Hofmann's bromamide reaction or Hofmann's hypobromite reaction. Another example is benzamide. Okay, here first and second. Okay, so here we will get after the reaction is aniline. Here the CO group is missing. So one in Hofmann's bromamide reaction, the product having one carbon atom less than the parent compound. Now I want to describe the Hofmann's Carbylamine reaction, that is one of the important reaction of amines. It is also known as Carbylamine reaction. Another name of this reaction is isocyanate reaction. It is considered as a test for primary amines in usual organic compound analysis in the lab. This test do not give by the secondary and tertiary amines. So here you can see the general reaction scheme for the Hofmann's carbylamine reaction. Hofmann's carbylamine reaction is that aliphatic as well as aromatic primary amines, when warmed with chloroform and an alcoholic solution of potassium hydroxide, yield the isocyanate or carbylamines. This carbylamine has a foul or unpleasant smell, so this reaction is known as carbylamine reaction. Here the side product is potassium chloride and water. So any primary amine reacts with chloroform and in alcoholic potassium hydroxide on heating give a foul smell by the formation of isocyanate or carbylamine. So this is one of the tests for primary amines, or we can use this test for the distinction of primary amines from the secondary and tertiary amines. Carbylamine reactions are those reactions when we are taking amine in a test tube we can add chloroform and an alcoholic solution of potassium hydroxide. On heating, if it is a primary amine, we will get an unpleasant or foul smell from the test tube. Okay. If it is a secondary amine, we will not get any smell, and this case is the same for tertiary amines. So this test is only for primary amines. Here you can see ethylamine, that is C2H5NH2, that is CH3CH2NH2, on reaction with chloroform in alcoholic solution of potassium hydroxide on heating give ethyl isocyanate. Here you can see the nitrogen atom is attached to the CH2 group. If it is attached, carbon is attached to the CH2 group, it is known as cyanide. Okay. If carbon is attached to the CH2 group, it is known as cyanide. But in the case of isocyanate, nitrogen is attached to the carbon chain. Okay. It has a foul smell. Along with this, potassium chloride and water is formed. And in second reaction, you can see here aniline reacts with chloroform in alcoholic solution of potassium hydroxide. On heating, we will get phenyl isocyanate or phenyl carbylamine with potassium chloride and water. So this gives a characteristic foul smell. So this is an important reaction used in the lab for the test for primary amines. Thank you for your attention.